Hi everyone, welcome back to our channel once again. In this video, we are going to study about another concept of RC circuit where we have pulse width equals 0.1 millisecond and time period equals 10.1 milliseconds. This is the condition for the input, and the input waveform what we are trying to give, step input, is this. And we want to draw the output waveform at the capacitor. What is the voltage of the capacitor for the given input? Okay, so this point, the pulse width is 0.1 millisecond and time period is 10.1 millisecond. This is 9 volt, this is 0 volt. So let's try to draw the output waveform for this. In the last video, the case was opposite. We were having the pulse width of 10 millisecond and the time period of 10.1 millisecond. Time period has not yet changed, but what changed is pulse width in this. And time constant, definitely it is tau equals 1 R into C, which is 1 millisecond. Okay, R into C if you do. Now we want to find out the voltage at the output, the output waveform basically for this. So let's try to draw the output waveform. 0 volt, sorry, this is t equals 0 at t equals 0.1 and this is t equals 10.1 millisecond. So first let's try to analyze this situation. So in this pulse width, WP is much lesser than tau, which is the time constant, and the time period is much more than tau because it is 10.1. This is 0.1 and this is 1 millisecond. So thereby what we can conclude from here is the capacitor will not charge completely because 9 volt is given at the input only for the duration of 0.1 milliseconds. For capacitor to completely charge, we require at least 2 or somewhere near 1 tau, right? More than 1 tau at least, because it requires 60 to reach the 63.2% of the output voltage. It requires 1 time constant, which is equal to 1 millisecond in this case. But what we have here is 0.1 millisecond. So capacitor will definitely start charging, but it will not charge up to 1 millisecond. After t equals 0.1, the capacitor, the input voltage switches to 0 volt. Therefore, the capacitor will stop charging, right? It will start discharging. When the capacitor starts discharging, it decays like this. But time to discharge is nothing but T minus WP. What we discussed in the last class is for the capacitor to completely discharge, T minus WP, time period minus pulse width, must be much more than tau, right? Time constant. Therefore, after reaching here a certain value, it will discharge completely and reach to 0 volt and stay 0 volt until we again switch to 9 volt at t equals 10.1 basically. So after 10.1, it will again go up, okay, and then discharge and stay and discharge. It will discharge quickly. So after 3 to 4 tau, again it will completely discharge and stay till 0 volt until the input is switched from 0 volt to 9 volt. Okay. So this is the output waveform so if you try to find out the equation for this, if you want to try to find out the actual voltage of what is the actual voltage here, for that you can put t equals 0.1 in the charging equation of the capacitor. That is nothing but Vc of t equals 9 into 1 minus e power minus t by tau, and tau is 1000, 10 power minus 3, right? Put t equals 0.1 milliseconds. Okay, this will give us somewhere near 0.856. Okay, so this is far cry from the 9 volt, right? The 9 volt is the maximum voltage the capacitor should charge if you want to charge the capacitor completely, but capacitor is charged only till 0.856, which is much lesser than the maximum voltage up to which capacitor can charge, as the input is 9 volt. Now after that it will discharge, it will settle down completely after 5 time constant. So it has enough time to discharge completely and stay at the logic low level. Okay, and the process continues further. Okay, so this is the waveform, output waveform at the capacitor output when we have pulse width much lesser than time constant and time period is much more than tau. See, the time period was much more than tau in the last case as well. Okay, so what matters for charging is here the pulse width. So if the pulse width is lesser than, much lesser than the time constant, the capacitor cannot fully charge. Similarly, if the T minus WP, if this T minus WP is much more than tau, then it has enough time to discharge completely. So what we need to look for is T minus WP for discharging and pulse width for charging. Both must be much more than tau for completely charge and discharge. But in this case, since we have pulse width much lesser than tau, therefore it couldn't charge completely, but it could discharge completely. Okay, and that's why the waveform is like this. It will never reach to a voltage of 9 volt. Okay, so that's all about today's video. In next video we'll try to understand when both the pulse width as well as time period is much lesser than the time constant.